Keystone Goes Off Topic with the Student Success Advisors. Mr. Lombardo is going to lead us, that's the word, lead us in some math magic. So thank you again for joining us for today's Keystone Goes Off Topic with the Student Success Advisors. Again, we are going to be doing some math magic with Mr. Lombardo. And see if we have any math skills here in the SSA department, and maybe some magic skills as well. So go ahead, Mr. Lombardo, take it away.
All right. So this shouldn't be too bad. It would be some instructions that we can follow, and you can play along at home. The only thing that we will need is some counting skills and a calculator. So make sure you have a scientific calculator if you have one. So you can use a smartphone, turn it sideways, and it should be good. Yeah. So the first one we're going to work with. First, I want you to think of a two-digit number. This can be any two-digit number at all. And you're going to add the digits together. So for example, if your number is 23, your addition would be 2 plus 3. Now I need you to subtract your answer from the original number. So for example, if your number is 23, 2 plus 3 is 5, subtract that answer from the original number there. Hopefully this works and I don't embarrass myself.
It's hard, so,
it can be. Oh yeah, totally.
Really helpful.
So this new number you have, remember it as your magic number. It's like that Schoolhouse Rock. I think it was Schoolhouse Rock. The number 3. Oh, so number 3 is a lucky number. Yeah. All right. So keep in mind your magic number, and I want you to find your magic number and concentrate on the symbol next to it. Let me know when you have your magic number.
Got it.
I'm good.
Yeah. I'm going to predict that your symbol is an I.
What?
Am I correct?
Yes.
So I'm reading your mind here, but let's find out why this works. So why this works? Yes, magic, exactly. So the reason this works, we'll go through the steps. Your two-digit number is represented as a binomial, which can be 10x plus y. When you add up the digits of the number, then it becomes x plus y. When you subtract the digits from the original number, the y's cancel each other out. So you have 10x minus x, which is equal to 9x. So that's the subtraction. So I have no idea what your original number is, but the idea is that every magic number, when it goes through this formula, will be a multiple of 9. And so the magic is actually in the chart, and that every multiple of 9 had the same symbol. And you can see it if we go back and take a look. You can see if you go down the first column and see the 9, you can see all the multiples of 9 going in a diagonal. So it's less magic and more of a nice little trick.
Yeah, some algebra magic, right?
Mm-hmm.
Blaser, what was your starting number?
I picked 18.
18. What'd you end at?
9. My math was very easy.
23, so we both picked small numbers. But
Right.
I picked 22, and I ended up at 18, which was the eyeball, obviously.
Mm-hmm.
That's so cool.
See, it's also a way to make sure that you know that you did it right, because if you don't end on a 9 or a multiple of 9, then you did that wrong. So Ryan was right, as long as we did our math correctly.
Yep. So this next one is sort of the same kind of thing, but you're going to need a calculator. Okay? So you can have a smartphone if you'd like. That would work just fine. turn your smartphone sideways so you have some functions, okay? A smartphone will do just fine. So I need you to pick a whole number between 2 and 9 and put that in your calculator. Okay. I need you to raise the number to the power of 12. Now you can do this by pressing the XY button on your calculator and then the number 12 and hit equals. You should come up with a pretty large number after that. Or if you don't have the XY, you could use the caret. There's a caret button. Kind of looks like an arrow pointing up. We both good there?
Yes, it's a very
Yeah.
good number.
Now I need you to, we're getting a little crazier, and divide that big number by 13. And you should come up with a fraction.
Or decimal. Should I move
Or decimal.
fraction?
No. It's a fractional number, so it would be a decimal. Yeah. Now look at only the fractional part, so the decimal part, and focus on the third digit to the right of the decimal. Okay? I'm going to guess what that number is.
Oh, no.
So remember, I don't know what your original number was. I have no idea, you know? But I'm going to guess that your number, so it's decimal, 1, 2, 3, that number is 6.
Yeah.
Am I right?
Yeah.
Yeah.
Magic.
Right?
I wanna
So
know
this
how
one-
works.
This one is a little more complicated. This theory was discovered in like the 1600s by a guy named, I think it's Pierre de Fermat, and it's known as Fermat's little theorem. And there's a whole Wikipedia page on this that gets really detailed. I just pulled out a little bit so you could kind of understand what's going on, because I really don't understand it. But if you're a math person watching this thing, go easy on me, okay? But
Or in the comments for us.
exactly, please. But Fermat's little theorem states that if p is a prime number, then for any integer a, the number is an integer multiple of p. So in notation of modular arithmetic, this is expressed as this equation: a to the power of p is equivalent to a mod p. So there's an example here for you that would come out to pretty much the exact same thing. But yeah, it's a really in-depth thing, but if you follow the instructions, you can wow anyone with some math magic.
Yeah, some fun magic to do with your family. And then not
Absolutely.
tell them how you do it, just say, well, it's magic.
That's the one I'm going to mess with you in the end.
Oh.
Oh,
So these are fun. I'm sure everyone, if you're on social media, has seen these. But this is the matchstick problem. So you would have to, for each equation, move one line to make it correct. Do you think we could do that?
Absolutely not.
personally? Or in
So
general?
So 3 times 9 makes no sense, right?
Uh-huh.
So think about what...
Being 5?
No, you'd have to make the entire equation correct.
Oh,
So you could move...
So it's
Yeah, so you could move like a matchstick from like here to over here, but this doesn't really make a number, you know? So how could you move a matchstick in here to make a number on this side and a number on this side?
So you're just moving one?
Just one, and it's correct.
Facial awareness is not something I'm gifted with. These were always my hard.
Well, the funny thing about making numbers like this is that almost every number is shaped exactly the same way, right? So if we take one stick, if we take one stick away from 9, this one here,
Uh-huh.
we have a 3.
Oh, so you just move that over there to
Ah.
9. That was so easy when you showed
Right?
us.
It's super easy once you have like that. Once you see it done, then it's like, oh my goodness, like
But you can only move
crazy. Mm-hmm.
in the next one, too?
Yep. Actually, I made a mistake in this one.
Okay.
My apologies. I actually made a mistake in... No, that one might be right. I apologize. I did not... That's... I made a mistake in the middle one. So, 8 times 3 does not equal 16. But how can we make this correct? You can kind of think like, what equals 16? You know, if I'm only moving one stick, then one of these numbers has to be correct in here, you know?
So can you move that bottom up and down line to the other side of the 3?
This one?
No, on the 3.
On 3? This one?
Yeah, to the other side to make it a 2.
You can.
Is that correct?
That is correct. 8 times 2 is 16. There are a couple ways
I've
you...
been able to figure these ones out before. This is so exciting.
There are a couple ways you can do this one. One of the solutions I have to this is keeping this stick right here and moving this one from here and making... 6 times 3 is 18.
Ah.
Yeah, so there are multiple ways you can do it. This last one is fun, though. So 5 times 8 does not equal 36. But again, there's at least one number in the equation that's correct.
Six times 6?
6 times 6 makes 36.
Oh, move the top, yep, right there, down to the, there we go.
Oh,
Perfect.
good job, Bridget. Wow.
Very good.
Good. Fun.
This is more of a logic problem, which is still in the realm of math, you know. But these are a great exercise. You know, keep your, just like little brain teasers.
I was going to say it's a fun game, but, you know, if you're doing your homework and you're bored with whatever you're doing a couple of these to switch it up, but still keeping your brain active and get it excited, you know, and then go back to your school. That's a good brain break.
Yeah, definitely. So this next one is, I'm going to try and not mess this one up. So here I'm going to read your mind again. So we have what is essentially a clock, right? I'm going to ask you to do a couple things here. This involves spelling as well. So,
Ooh, dangerous.
if you don't know how to spell the word 12, don't choose 12.
Ah.
Oh, I thought you were saying
Okay.
that word.
There we go. So what you're going to do is you are going to pick a number, any number on the clock whatsoever. You can pick 12 if you want. And you're going to spell the letter out by counting the numbers around the clock. So for example, say you chose the number 4, right? Starting at 12 and moving for each letter, you would go F, O, U, R. Okay? So go ahead and choose a number. And spell it out. So I'm going to do 4. I'm going to go F, O, U, R. Now you should be on your next number. Now I want you to spell that number starting with the next movement. So since I landed on 4, I'm going to go to 5 and say F-O-U-R. So I want you to then spell out your next letter, or your next number. And you should be on a brand new number after that. Yep. So now, I'm going to ask you to do it one more time with the number that you're on. With that new number, spell it out. And keep going around the clock if you have to. All right? Now, I know that you're not on the number 2. Nope. I know that you're not on the number 8. And I know you're not on the 12. I also know that you're not on 4. Okay?
Mm-hmm.
So the number that you're currently on, I want you to spell one more time using the numbers that are existent on the clock.
Spell the number of the online.
Yep. You good?
Mm-hmm.
I'm going to guess that you are on not 11, not 10, 9, 1, 3, or 5, but the number 6.
Yes.
Yes?
Magic.
Math magic?
I shamelessly stole this one from a David Copperfield skit from the 90s, so everyone knows where that one came from. So this is the way this works is miraculously, the way that all the numbers are spelled, the number of letters in each number, if you spell out the numbers in this fashion 3 times, you're always going to end up on the number 1. And then when you take out, at the very least, the 2 and the 4, and then for sensation, you take out a couple others, you will always have 1, or O, N, E, and you end up on 6.
That makes sense. It's crazy to think that it works, but it makes
Yeah.
sense.
And that is our math magic for the day.
Thanks, Mr. Lombardo. I know you blew my mind with that math magic. That was really exciting.
I hope everyone had fun with
problem. Yeah.
Yeah, that's pretty cool. Let us know, what math magic do you like to do? Do you know any other math magic that you could share with us? Type it in the
it. Do leave them in the comments.
Yeah, leave them
Down
in the
there.
comments. And don't forget to join next week for our Keystone Goes Off Topic with the Adult Learning Team next week. And check out all of our previous Keystone Goes Off Topic on our YouTube channel, the Keystone Sports 74. Thanks for joining us and have a wonderful day.
Bye, guys.